Hello everyone, welcome to Webcoach. I am Arishin Anwal and today we are going to discuss our new topic that is chemical bonding. So I'm going to take up the class 11th chemistry. So the topic which we have is chemical bonding and molecular structure. So what all topics we have to discuss today, let's see. First we have introduction, then we have Lewis-Langmuir concept, then we have covalent bonding, resonance and Vesper theory, that is VSEPR theory. First we have introduction. So the first, because since the topic is the chemical bonding and the molecular structure, so first we need to know what is a chemical bond. So what a chemical bond is: the attractive forces that hold various constituents such as atoms, ions, molecules, etc. together in a different chemical species is known as a chemical bond. So if you see that chemical bond is nothing but it's just the attractive force between the different constituents. It may be ions, it may be atoms, etc. in different chemical species. So that is what the definition of a chemical bond. And with this chemical bond, this entire terms of chemical bonding comes in the picture. Now, if the chemical bonding is coming into the picture, there were many scientists who tried to discover how bonds are formed. Now, because since we know we have what all we have discussed, we have discussed how atoms were formed, how ions were formed, how they were combined together and all that in our previous chapters. All this we have discussed, and we also have discussed the elements which were formed during a long course of time. But we also knew that there were many compounds in this universe. There were a lot of compounds. So how these compounds or how these chemical species were binded together, all this was the new era of thinking, or you can say all the scientists were trying to focusing how these two chemical compounds, or how these two chemical species, such as how these two chemical constituents, they combine together in a chemical species. That was a new catch thing which bring about all the terms of chemical bonding and all that. So with this we are going to pick up and we are going to see what all do we have. So first we have Lewis-Langmuir concept. So Lewis was the person, there were many scientists who were were doing all this discoveries, and who were actually working upon these upon the different species, and how they were they were actually explaining how all this was happening. So Lewis was the one whose work was actually recognized, and what he actually said was, we will be discussing that in details. So Lewis, he pictured the atom in terms of a positively charged kernel, and the outer shell could accommodate a maximum of 8 electrons. Now, since I am not going to define what is a shell, what is an electron, because now we are actually very, you can say, very known. We know all these terms: what are electrons, what are shells, how many electrons a particular shell can accommodate, what are S shell, P shell, D shell, F shell. All this we know. So I am taking this into consideration, that I know all these things. So I am gonna pick up from there, and I am gonna tell what is coming beyond that. How now my main focus over here is to determine the chemical bond in between two chemical species. So that's how if we look into the Lewis-Langmuir concept. So in this way he defined that the nucleus and all the electrons. See, if you have say sodium atom, then it must be having an outermost shell, and then it is having inner shells, and then it is having a nucleus, right? So the nucleus plus the inner electrons, it constituted as a kernel. He said that portion as kernel, which consists of the nucleus, the positively charged nucleus, plus the inner electrons, and the outermost shell. So there were two parts of an atom. First, the kernel, which constituted these nucleus and the inner electrons, and the second one was the outermost shell, and this outermost shell could accommodate a maximum of 8 electrons. This was what he said. Now he further assumed that these electrons could occupy the corners of a cube which surrounded the kernel. Now if you picture a cube in your mind. So cube has 8 edges. If it has 8 edges, so what he said was that all these 8 electrons, because the outermost electron could accommodate a maximum of 8 electrons, so the cubes of the edges of the 8 electrons, so the edges of the cubes, they were actually accommodating an electron over there. So each electron was present on the corner, or you can say on the edge of the on the cube which surrounded the kernel. So kernel was inside the cube, and the cube consisted of 8 electrons present on the corners. Thus, the single outer shell electron of sodium would occupy one corner of the cube, because see, what is the electronic configuration of sodium? It has 1s2, 2s2, 2p, what is it, 2p6, 3s1. That is so the outermost shell has 1 electron, that is 3s1. So that 1 electron, since it is having only 1 electron, so in the cube only 1 electron will be occupying that corner. Only one corner will be occupied by 1 electron, and the other kernel will be present inside the cube. Or maybe if you say a noble gas. Now noble gas has a full configuration. If you say neon, for example, or say argon, for example, it has 8 electrons.